Hi, chemistry students. We are going to be talking about acids and bases today, and that's what we're doing this week, acids and bases. I've got three parts to the lesson, so basically three lessons today. We're going to do an intro to acids and bases, just kind of review what you probably already know and just kind of put it into some context. And then the second part is I'll talk about pH scale, and what it means. And then we'll introduce the hydronium ion and the hydroxide ion, and that's what makes things acids and bases. And then the third one is pH indicators, all the different kinds, and then what neutralization is and how it works. So that's the plan for today, three parts. Let's get into the first part, intro to acids and bases. And I just want to point out that acids, you probably know this about acids, is that acids there's a ton of foods and drinks that are acidic, and acidic things usually taste sour. So sour drinks, like anything with citric acid, has a little bit of sourness. We tend to like things that taste sour. So acids tend to be sour. Lemon juice is a good example. And then bases tend to be soapy. And then either acids or bases, when they are in their concentrated form, can burn the heck out of your skin. So both acids and bases are very capable of doing chemical burns. Okay, but sour, soapy, and burning. Okay, so another thing you might already know about is pH balance. You've probably heard about that. What in the world is that? We'll talk about that a little bit. And mostly it's a marketing gimmick, but they can actually do chemistry to make it pH balanced. But let me just point out the other marketing gimmick that this same shampoo bottle has on it. It has this thing with micellar technology, which the shampoo bottle advertises that the shampoo makes micelles, which, if you remember what we were talking about with soap, that's how soap works. So pretty much shampoo is like, hey, we're shampoo. So anyway, take the pH balance in about the same sense. Okay, so let's look at acidic, neutral, or basic. We're trying to figure out what things are acidic, which ones are neutral, and which are basic. I've got a big long list of all kinds of things. We've got tomato juice. Is that acidic, neutral, or basic? Ammonia, Drano, seawater, hydrochloric acid, coffee, oil, vinegar. There's all kinds of things, and all these things have to be either one of the three. They have to be acidic, neutral, or basic. We could probably get some hints, like hydrochloric acid. The fact that it says acid is a good hint that it's acidic. We've also got car battery acid would be another example of, well, it has to be acidic. The other ones are a little bit more fuzzy. The one I'd like to point out is, like Tums antacid. So anytime it says antacid, that's short for anti-acid, and that's a good indicator that it is a base, because it is anti-acid, the opposite of an acid, and that would make it a base and not neutral. So the rest of these we will just try to figure out throughout the rest of the lesson, and we're going to look at most of them. Okay, let's see. So in order to figure out whether something is an acid or a base, we need to use some sort of indicator. And I've got this paper that has a couple of chemicals on it that turn different colors depending on what kind of pH they are put in. So something with a pH of 1 turns pink, something with a pH of 12 turns purple. We'll figure out what those numbers mean later on. But let's just look at what we know. So this is universal indicator, as this nice rainbow of colors, depending on the pH that we put it in. So here I've got vinegar. And now if we look at vinegar, we go, okay, is vinegar an acid or a base? And you can get a hint, luckily, from this picture. If you don't know, we can see that it says 5% acidity. that's a good hint that it is acidic. And also you can think, is vinegar sour? Yes, it's very sour. It's what makes a lot of things that we like to eat sour, pickles and all that kind of thing. It's the vinegar that makes them taste good, gives them that sour taste. So vinegar is an acid. And I just want to point out that you look here on the little piece of paper, on this indicator paper, I dripped a little drop of vinegar on there, and you notice the paper started out orange and now it is a pretty bright pink. And it's hard to tell, I will admit, I need to get some better lighting if I'm going to keep on doing this videoing and photographing. But if you can tell, I'll just tell you, it's a 2. So the pH of vinegar is a 2. You can see it's kind of pink. That means it's right down here. So we know, first of all, that vinegar is an acid, and we know that it has a pH of 2. So we also know that a pH of 2 is acidic. Okay, so we know that. Let's look at something else. These antacid tablets, like I said, an antacid stands for anti-acid. So that anti-acid means that it is the opposite of a acid, which means it is a base. And I'll just let you know that we know that it's a base. So when we put this, the paper, we drip the stuff on the paper, unfortunately, I just put way too much on there, and it ended up just, bleeding off of the paper. So I'll just point out that when I first put it on there, it was a nice blue, and then you can kind of see a remnant of the blue before it all went away. So the pH of the antacid tablets was right around here. It was a pH of 10, this nice blue. So if we know that antacid tablets are a base, and we know that they had a pH of 10, that means that a pH of 10 is a base. So we know this is an acid, pH of 2, a pH of 10 is a base. And then we'll look at distilled water. I took some distilled water, put that right in there. It was hard to tell, it didn't change much, but then I did notice that the little bit of the indicator that was still on the paper was yellow. Anyway, so I got, is water an acid or a base? Neither. It is neutral, and the pH of the water is 7. So neutral is 7. pH of 7 is neutral. So acid, base, neutral. Okay, so let's look at a bunch of other things. We've got pop right here. So we got some Sprite. And the Sprite, notice, it's pretty pink there, So that is in the acid range. So everything on this side is an acid. Everything on this side is the base. So we got soap is a green. That was right in here. The lime juice here, notice very pink. It was even more pink than the Sprite. It's way down here at 2. If we called Sprite a 3, then lime juice would definitely be a 2. Baking soda, you can notice, is greenish. That's right in here. It's hard to tell the color, but I can't remember what, I wrote it down, but I think it was right in the 8 or 9 range. Okay, so then we've got isopropyl alcohol. Notice it didn't change the paper much, so it's right in here in this 6, 7 range. The orange juice definitely made it more in the orangey pink range. So acid, milk of magnesia, holy moly, that is very moving toward purple. So I called it an 11, this dark blue. So very basic. This is another antacid that people take for their acid troubles and indigestion. So that is a very strong base. And then yogurt, notice that it's a little bit acidic. So I put that right around a 4-ish. Bleach. The problem with bleach is as soon as I put the bleach on there, it turned bright blue, or not bright blue, dark blue. It was like over here. And then within seconds, it bleached the paper. So I wasn't able to show you the color fast enough because by the time I got the camera around, it was all bleached up. So I'll just tell you that it was a nice dark blue, so a very good base. And then it bleached paper. Sauerkraut kimchi is, ooh, nice bright orange, orangey pink, and that is because of all that vinegar that gets made in the sauerkraut or kimchi. Milk, pretty neutral, just right around yellow. And so here's all the stuff that I did, and I put in the numbers that, as far as I could read them, it was hard to tell, from, your estimating colors. But this is about where I put them by their colors. Notice all the acids are up here on the top. We've got lime juice is 2, kimchi with vinegar basically is a 2, vinegar is a 2. Pop and orange juice are right in there at 3, and yogurt is a 4. All of these guys I would call neutral. It's hard to tell from the coloring, but I'd say isopropyl alcohol, sugar, oil, milk, distilled water, and dish soap all were 7. And then we've got soap, hand soap, and baking soda, ammonia, antacid, Tums antacid, and then milk and magnesia and bleach, all bases. And they're getting stronger bases as we go down this way. So milk and magnesia was stronger than the ammonia. All right, so that is all the different products we tested, that I tested. I would have had you guys tested if we were in the lab, but we can't do that. Anyway, so let's look at this list. This is what I'd like you to do, is just go through these and try to figure out if it's acid, neutral, acidic, neutral, or basic. And I'll just give you a little bit of time. In fact, it wouldn't be a bad idea to pause it for a little bit and think about it. Try to figure out whether they're acid, neutral, or basic from what we saw. In fact, I'll just sit here and wait while you think about that. Does that fit with what you thought? So all these acidic things, vinegar, vitamin C, pop, yogurt, battery acid, tomato juice, black coffee, hydrochloric acid, lemon juice, and orange juice, all are acidic to varying degrees. The hydrochloric acid and the carbattery acid are more acidic than, say, yogurt or vitamin C or coffee. They're kind of on this side, but they're still acidic once they're on this side. And then on this side is all the basic things, milk and magnesia we saw, lye, which would be what they make soap out of. It's a super strong, sodium hydroxide is lye. And then we got bleach, we saw that. Drano, I didn't even want to touch that because that stuff's so strong, I didn't want to burn myself. Drano, and let's see, we got ammonia is also basic, soapy water is basic, seawater, and Tums antacid, if we saw too. So all of those are a little bit basic. These guys are a little bit basic, and then some of them are very basic. And then the neutral things are oil, distilled water, salt, milk, isopropyl alcohol, gasoline, and sugar, kind of right in the neutral. All right, hopefully that worked.